everybody. Okay, we're going to start a little bit early because we're just not going to get any more people in the room. So, yeah, basically, welcome to this CEN talk. I'm so glad to see so many of you here today. This is Carmen Torres, and she is a mechanical engineering lecturer at Heriot-Watt. She has an interest in functionally graded materials and engineered materials, and hence is looking at bamboo and how we can use that to create low-cost housing opportunities. Okay.
Thanks very much. Thank you, Rebecca. Thanks a lot. Well, thank you for coming. It's amazing to see so many people. And I feel a little bit sorry that people have to stand while they're eating their lunch. I repeat again, there's another free chair here at the front for anyone who doesn't feel too shy to take it. Yeah, brilliant. As I say, thank you for coming. Yes, very good. Thank you for coming. It's a pleasure for me to be here speaking to you about this project that has been ongoing for about 2 years now. I'm a lecturer, but I'm not here, as I told Rebecca earlier, to lecture you. So I would really appreciate if throughout the presentation, if you can think of a question, do shout, okay? Do ask me without waiting until the end of the presentation, so we can do something a bit more dynamic and interactive. I'll be very happy if you do that. Right. Okay. So the first thing I'm going to do is to take you through the outline for the presentation today. So first of all, we will talk a little bit about the motivation, why I got into these, although Rebecca has already mentioned a little bit about that. And in chronological order, take you through the different steps, different stages that the project has had so far and what we are planning in the near future. And obviously, there's a story underpinning this talk, and it will flow naturally, and you'll see how it unfolds with guest speakers as well, who are going to help me tell you the story of bamboo huts as low-costing solution in developing countries. So the motivation really is that people in the private areas, people who have not access to housing because of economical issues or cultural issues or status issues, they have a very specific view of what a house would be, and they always look up. They always want a square. Let me see if I can get the pointer right. Yeah, they want a brick square box, because this is what they understand is a house is. So brick and mortar as raw materials and a square shape. This is what they think a house is, and this is what they aspire to. And this picture here is really to draw your attention to the roof. As you can see, is corrugated tin, and this is a point I will make later on in the presentation. Because despite of this material not being very friendly in terms of comfortability in spaces, people still use it, which is a very interesting thing going on in this project, that despite us knowing what works from a mechanical engineering point, from a structural engineering point, from a materials viewpoint, the people over there, the locals, do not necessarily apply it. They're not putting it into practice. So there's a cultural factor here that is really, really interesting in this project and makes it very complex as well. But this is something that I will touch on in a minute or two. Right. People who would be beneficiaries of this low-cost housing solution are people who currently live in places like this, in slums, in suburbs of the private areas, in India in particular. This place is Spawal in Pune, in India, and they use this structured as residential dwellings, but also as, like, for example, livestock shelters and farming shelters as well. Raw materials, not vegetable materials, raw materials, things like steel, concrete, etc. They are scarce. They don't have very much, so they need to be able to use it properly. So one of the great realizations for them was to look around and see they had a lot of bamboo. Bamboo is something that they call a giant grass, and it grows real fast. It grows about 30 centimeters a day. Can you believe it? 30 centimeters a day. And you can harvest bamboo, like proper poles of bamboo. I'm sure you've seen, if you haven't seen bamboo itself, I'm sure you've seen like some decorations in spas and on hotels, etc. They do have these bamboo poles. They can harvest those in about 3, 4, 5, even 6 years, which is amazing. It's remarkable, because if you compare that to timber, that takes about 30, 40 years to become a proper construction material. This is a real asset that they've got over there, and they're not kind of exploiting it. And this kind of technical looking slide is here in a way to link what Rebecca said during the presentation about myself. When she introduced me, she said that I'm someone interested in functionally graded materials, which is actually my research interest. I do work in modeling, simulating, and design and manufacturing materials that can be multifunctional. They don't only have one single function. For example, only a structural material. They do have more. For example, they are biocompatible, and they can be used in bioengineering, or they are they've got some sort of thermal or sensing capabilities, etc. But bamboo is a natural, functionally graded material, and this is the reason why we are interested in this material. And it's all this is all to do with the way that the different parts of the plant, the lignin and the cellulose and all that, is distributed in the plant. The cells, these are ICM images of bamboo. As you can see, it's got a beautiful structure, a heterogeneous structure, cellular structure inside there, and there is a purpose for it, or nature has a purpose for bamboo, which is that the mechanical properties are extraordinary. I understand most of you have a technical, scientific background. Yeah? Is there anyone from arts or? Yep, okay. So if you feel dizzy when you look at this equation, just look away. Yeah? No. This means, and especially to you, I can explain this to you, this very high value here for something that we call G. This means that the bamboo pole bends without breaking. And this is really, really interesting when it comes to vibration absorption. So for example, when imagine there's an earthquake and the energy from the earth needs to be transferred somewhere. But if the material that is being transferred to is stiff, is solid, put it that way, it won't be able to absorb the energy, so it will probably fail. It will have like a brittle failure, for example. However, if it's a porous material, like for example bamboo, it will absorb the vibration, and therefore it will not have a catastrophic failure. Does that make sense? Yeah. So this is really, really interesting for the bamboo from a mechanical engineering viewpoint, that bends without breaking. Obviously, mechanical properties of bamboo are also quite extraordinary. In this graph, apologies, probably people at the back can see it very well, but this is specific strength. This is the strength of a material. This is the toughness, how tough it is. Okay. Here, it's plotted here, and this is the modulus. Okay. So this is like the actually the modulus is more to do with how tough something is, and this is the strength, is how much you have to put energy into to break it, okay? How resilient it is. So for a graph like that, the engineering alloys are in this kind of cloud, in this area here, and polymers are in kind of this cloud here. So and bamboo, quite remarkably, as I say, is up here. So it's got a really high Young's modulus and gives a lot of strength as well. So a humble natural resource that these people have, and they don't exploit for something that I'm going to say next, is definitely an opportunity that we saw, and we thought that it would be criminal not to give the know-how to these people, or people who are in need of low-cost housing solution as a midterm, or even disaster aid shelters. You know, for example, if there is an accident or something. And I'm going to give you a few seconds to read this quote, because it's very interesting and important at the same time. And it's amazing that you go there, people go there, and show them the possibility, the potential that bamboo has, and they still don't like it. They don't like it because they aspire to a brick, square shape, box type of house. And it's all very nice that we do, and when I say we do, I mean first world here, Western Europe, graduates and very educated people. We do a lot of design, and we do a lot of assemblability studies and strategies for allowing them to have a DIY kind of flat pack, IKEA type of bamboo house. But the culture is really stopping us from, or is stopping them from being empowered because of this issue, because they see bamboo as a material for the poor, because it's just there in their garden. It's just a weed. It's just there, right? There's a slide. That's right. That was the slide I was looking for. This house is in South America and is made out of bamboo. So it's really, you can come up with really sophisticated designs for houses. And when locals, when communities get the point, it's really powerful. It's a really powerful message. And not only in terms of empowering the communities and giving them a place to live and giving them a better future, etc. It's also in terms of sustainability. It's a very important aspect, because the energy that it takes to produce a cubic meter of concrete, a cubic meter of steel. I don't have I didn't want to put a lot of numerical information on this presentation, but the energy that is used to produce those materials compared to the energy needed to process bamboo as a raw material for these constructions is amazing, it's appalling. It's like 2 orders of magnitude. So bamboo definitely has a great potential there. Okay. So our vision, yes, please.
So people probably come in who prefer concrete and steel say to you, well, that's all very well, but what about my building lasting for 20 years? What about insect attack? Those types of concerns. Are those
this is a great question. Oh gosh, it feels as if it was timed or something. Because no. Right, because the answer is on this slide. Oh, fantastic. So thank you for the question. What's your name, sorry? Catherine. Catherine. Thank you, Catherine, for your question. The answer is here, because our vision was to come up with a kit, with a flat pack kit of connection, prefabricated connections. The bamboo is going to have, as you very well have pointed out, it's going to have a limited lifetime. It's going to be, it's approximately 5-6 years.